Okay then, so we have a class now with private properties and public methods that we can use to update the pizza objects that we make. Now I want to show you how we can use this class as a type. So down here, I've already created 2 instances of a pizza using this pizza class, and we've called those objects pizza1 and pizza2. Now when we do this, TypeScript automatically infers the type of these objects to be of type pizza, like the class name, and we can demo that by hovering over the variable names and looking at the type, which is pizza. So we saw this kind of type inference earlier in the course when we worked with built-in types like strings and numbers. But this time, TypeScript is inferring a custom class type, which is awesome. Now we can explicitly annotate a variable to be of a class type as well in the usual way by adding a colon after the variable name and then whatever the class is called, in our case, pizza. But again, this is not necessary because when we create a class instance like this, TypeScript can just infer the type. We can also use this class as an argument type inside functions. So let's try that out as well. So what I'm going to do is come down here and create a new function. And this function is going to be called add mushrooms to pizzas. Now then, as an argument, we're going to take in a property called pizzas, right? And that is going to have a specific type. It's going to be an array of pizzas. So array. But the type of objects inside that are going to be of pizza type. So we can just say pizza array. Alright, then we're not going to return any value. So we'll say void right here. Then inside here, I want to loop through the pizza array. And I want to add an ingredient mushrooms using the add topping function to each pizza. So then I will say for, and we'll say const p of pizzas. So this is how we can loop through an array. It's a bit like for each. And then I will take each pizza, which we refer to as p, and then I will use the add topping method on that. And the topping that we're going to add is mushrooms, much like the name of the function says we will. Okay, so now we can call this function. I could say add mushrooms to pizzas. We need to pass in an array, and that array needs to be of pizza objects. So we can say pizza 1 right here. We can also say pizza 2. But if we try to add in another object that's random, then it's not going to accept that, obviously, because it's not a pizza. All these things have to be pizzas inside this array. Awesome. So then finally, I'm just going to come down here and console.log to make sure this has worked. Both pizzas, pizza 1 and pizza 2. And both of them should just have the mushroom ingredient because we've not added any other ingredients onto these yet. We're just giving them a title and a price. So let's save this now. And then if we open up the terminal, scroll up a little bit, we should see 2 pizzas. Yep, okay, there's the first one. So we have a title Mario Special, price 15 base classics, and there is the toppings mushrooms. Down here, Luigi Special 10 classic and mushrooms. Awesome. So this reference has worked, and that is how we can use classes like this as a type, either to type variables or to type arguments inside functions. Alright, so we're making a bit of progress with this class now, and we know how to use this class as a type as well, either for variables or arguments to functions. Now I want to imagine that I might be making some kind of menu application for takeouts to use to add new menu items to their online menu. And for that we'd need different classes, right? For different food types. Because each type of food would have different properties. For example, for the pizza class we have base and toppings. For maybe a noodles class we might have the noodle type, fillings, and sauce. For a burger class we might have, I don't know, a patty option, a mayo option, cheese option, and so forth. So we'd need these different classes for these different food types. However, in each case, for each menu item type for each food type, they'd all have some properties which were common. For example, all menu items would have a title and a price. They wouldn't be unique just to pizzas or just to noodles or whatever else. So for each class that we make, for each different type of food, we'd have to have those properties wired into it, right? And that seems a bit repetitive and unnecessary to add these 2 properties, the price and the title, to each one, because we'd just be repeating the same properties over and over and over again for each class. So instead what we could do is make another class called menu item. And this menu item class would be like a parent class to all other food classes. And it would contain all the properties that every single menu item has, regardless of the type of food it is. And those properties would be a title property and a price property, because every menu item needs those two properties. And then when we have that class, we could make it so that every other food item class, like the pizza, inherits from that class. And that means they automatically inherit any properties defined in that class. In this case, that would be the title and price properties. So what I'm going to do first is define a constructor method in the menu item class to take in the title and price. And we're going to set them up in the same way as before using private modifiers as well. So let's just copy and paste that from the pizza class. And now we have this menu item class, and we want our pizza class to inherit from it. And the way we do that is by saying pizza extends and then menu item. And that means it inherits everything inside the menu item class. Now, when we make a new pizza item, we're still going to make it in the same way. We're still going to say new pizza and pass in the title and the price. But we're no longer going to be manually setting those properties in the pizza class itself. Instead, we need to pass those into the parent class that we extend from so they can be set there. And the way we do that is by using a function called super, which we have to call inside the constructor function. And we are actually getting an error right now because we're not calling that super function. So then invoke it and then pass in whatever arguments the parent class constructor accepts. In this case, it's the title and price, which we have access to. So when we make a new pizza, we still pass in the title and price. We accept them in the pizza constructor. And then we call the super method and we pass in those values. This in turn runs the parent class constructor, which receives those values and sets them up as properties. Now there's one more thing we need to do, and that's to take off the modifiers in the pizza class in the constructor, because we're setting those values in the parent class now and we don't need them here anymore. Alright, all done. So now anytime we have a new food class, whether it be a pizza, pasta, noodles, or something else, we can have those classes extend this menu item class. Alright, so there's one more thing I'd like to do, and that is to give the menu item a function called details. And because we're giving this to the menu item, it means that automatically any instance of a pizza or any other class that extends menu item is going to get access to this details function as well. So this is going to return a string right here. And inside, all we're going to do is return a template string where we're going to output the title and the price. So $curly braces to output a variable, and then we refer to the title. So this dot title, and that gives us this property. And then we'll do a dash, and then we'll output the price. It's going to be in pounds, so $sign first, then $curly braces to output the variable, then this dot price, which gets us this property. So now we have this details function, and what we could do to use that function is come down here at the bottom, and we could say pizza dot details, and we could invoke it like so, right? Now, sometimes we don't want to invoke a function, we just want to use it as a property. So instead of saying details and invoking that, we can just say pizza.details. And for that, we can use something called a getter. So all we need to do is place get in front of this function, and then it treats this like a property rather than a function. So now we can just say pizza.details without invoking it, because invoking it would mean that we're actually calling the function, and we get an error if we try to do that. So instead, we get rid of this, and we just use this as a property instead. Alright, so what I'm actually going to do is create another function down here. So I'll say function, and then print menu item. And then inside that function, we'll take an item, which is a menu item. So that's the type of arguments. And then this is not going to return anything, so I'll say void. And all we'll do is console.log the item, and then if I press dot, we can see we have access to that details property now. So we're going to log this thing to the console. And again, this would be available for any menu item. So if we had classes like noodles or burger or whatever else is that inherits or extends this menu item class, then we're going to get this details property on any of those things, okay? So we can pass a pizza through as the item. In the future, we could pass a noodles object through, or it could be a burger object through. let's try this out with the pizza. I'm going to say print menu item, and then we're going to pass in the pizza right here. Save that, and let's open up the terminal to make sure it's worked. And we can see Mario Special is £15. Awesome. So now we've created this parent class menu item, which the pizza class extends right here. And in the future, if we do ever make other food items, they could extend the menu item class as well. Alright, we're making some good progress with this class stuff now, and there's just a couple more things I want to cover before we put all of this together and make a mini project. The first thing I want to talk about is how classes can implement interfaces. So remember when we talked about interfaces, we said that they basically defined a structure of an object, what properties it should have, and what type of data those properties should hold, whether it be string, number, boolean, or some custom object. Now, when it comes to classes implementing an interface, we're basically setting up a contract between that interface and the class. And in that class, we must have the properties defined within the interface. But like always, I think the easiest way to approach this is by jumping straight into an example. So let's make a new interface first of all, and then we'll have the menu item class implement that interface. So I'm creating this interface called hasFormatter, and I'm going to say that anything that implements this interface must have a format property, which is a function. And this function must return a string. So now what we're going to do is say that the class menu item is going to implement this hasFormatter interface. And the way we do that is by using the keyword implements, and then whatever the interface is called, in our case, hasFormatter. Now we get an error right here, and if we hover over that, it says class menu item incorrectly implements the interface hasFormatter. Property format is missing in the type menu item, but required in type hasFormatter. So currently this is not implementing this because we don't have this format method defined within this class. So let's head in. We're going to say format, like so, and we're going to return a string. Now I'm just going to grab the string from my course files on the GitHub repo and paste it in. And all we're doing here is returning this string that says this menu item is called this.title and is this.price. So that's all we're doing. And now we no longer get the error, and the menu item class is correctly implementing the hasFormatter interface. Okay, so now we have the menu item class which implements the hasFormatter interface. But how is this useful? Well, there might be several different data types in an application which implement this hasFormatter interface. And they might be totally different data types. Some could be menu items, some could be user objects or order objects or something else entirely. And by binding them all together with an interface, we have a way to add functionality in the application for any object which implements that interface. For example, I'm going to create a new function now called print formatted. And that function is going to take in an argument called val. And as a type for the argument, I'm going to specify the hasFormatter interface. As a return type, we'll just say void. And then inside the function, I'm just going to say console.log. And then inside that, I can say val, then a dot, and then we're going to see the format function, because TypeScript knows that any object, whatever it is, that implements this hasFormatter interface has that format function. So if we think about this, now if we have loads of other data types in the future that all implement this interface, then it doesn't matter really what type of data it is, as long as they have that format function, they can be accepted into this as an argument. So it kind of makes our code more reusable and it binds things together in a way. So, well, let's try invoking this function and passing in our pizza object. And then when we've done that, we can save the file. And we're going to look inside the terminal. And when we do that, we should be able to see the formatted menu item. Awesome.